a whole lesson now devoted to the converse of the Pythagorean theorem. And actually, the converse of the Pythagorean theorem is used in building projects all the time. Let me teach you how. This guy's installing an egress window in the basement, and he first carefully tapes out his rectangle, and then he has to make sure before he puts the window in that that's a nice right-angled rectangle. So the right angles are key. That's how the Pythagorean theorem can help. Now he knows that his opening is supposed to be 4 feet by 5 feet, or 48 inches by 60 inches. So what he does is he measures from corner to corner diagonally and gets that measurement. And the idea here is that he can use those 3 lengths to decide if he has a right triangle, or in other words, if this angle is a nice 90-degree angle like he hopes. Let's do the math for him. 48 squared plus 60 squared, does that equal 76 7/8 squared? Well, 48 squared plus 60 squared is 5,904. And 76 7/8 squared is 5,909.8 approximately. So what I'm seeing is that the 76 side is just a little too big, isn't it? So if that diagonal is a little too big, he's going to need to do some adjustments, right, to make it just a smidge smaller. He'll want to keep the 48 on this side and the 60 on this side, of course, but maybe shim it up, maybe stick some shims in there that just kind of taps it up a little bit. So that hypotenuse would just be a bit shorter to get a nice perfect right angle in the corner. So the official converse of the Pythagorean theorem says that if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other 2 sides, then the triangle is a right triangle. In other words, if a squared plus b squared equals c squared, then you know you have a right triangle. So the way that you'll have to apply that is by checking out 3 numbers, putting them into a squared, b squared, c squared, and seeing if you'd have a right triangle. This first one is just a little tricky because did you see they gave me this second length in simplest radical form? I recommend you type in 4 times the square root of 3, and it comes out to approximately 6.93. The only reason I do that is because I may want to make sure that I know which one is the longest here. And so I know that the 8 is the longest number, so I want to use that as my C. So I'll plug in the 4 for A, and the 4 square root of 3 for B, and the 8 for C. And what I'm checking is to see if those are actually equal. 4 squared is 16. When I square this next one, basically what I'm going to do is I'm going to square the 4 and I'm going to square the square root of 3. Well, 4 squared is 16, and the square root of 3 squared is square root of 3 times square root of 3 would be square root of 9. Square root of 9 is 3. So basically that square root and the square cancel each other out. (16 plus 48 on this side is 64. And so what we found out is that those 3 lengths would form a right triangle. Not too bad. All we're going to do is we're going to check to see if these fit in a squared, b squared, c squared. Always using the longest length as our c. I just found out that these would not make a right triangle. And if it's not a right triangle, it must be an acute triangle or an obtuse triangle. Let's do one more. This one has a radical again in there. The square root of 61. I'm going to type that in. And I do that because I want to make sure that I'm using the longest side as my C. And it turns out that that is my longest side this time, so that's going to go in for my C squared. The square root of 61 squared, squares and square roots are opposite, so that comes out to 61. And this side comes out to 61. So I just found out that, yes, I found another 3 lengths that would make a nice right triangle. For the next example, we're going to look a little more closely at this one that was not a right triangle. So we found that a 10, 11, and a 14 did not make a right triangle. So this picture right here is a lie. And I always like to blame the C side. I like to blame the hypotenuse. I think that'll help if you get in that mindset. So we're going to look at what's wrong with that hypotenuse. Well, in this case, the hypotenuse was the 14, and the 14 wound up being not big enough to match that 221, right? That 14 was too small. So that means that the 14 was too small to make that a nice right angle down there, right? So if it's not a right triangle, is it acute or is it obtuse? Well, since I had to tip my triangle this way because the 14 was being all too short and everything, this angle down here is too small to be a right angle. So that's what I want you to remember. If that C side is too short, we're talking an acute triangle. Where if the C side winds up being too long, we'd be talking an obtuse triangle. If that 14 had been too long to make a nice right triangle, then that angle would have been bigger than 90 degrees. We're going to practice that concept. So we're going to use the lengths 3, 4, and 6. The first thing is kind of a throwback. I want to see, can you even make a triangle out of a 3, a 4, and a 6? Do you remember how we used the longest one to think of that as like the river? If you had a 6-foot river, could you make it across with a 3 and a 4? And I would say yes, because 4 plus 3 is greater than 6. So yes, we can form a triangle. And then we're going to classify that triangle. And the way that we classify is we use the Pythagorean theorem, that longest side being our C. And what I found out is that it's definitely not a right triangle because they don't equal. So now I have to figure out, is it acute or is it obtuse? Do you remember which one I was blamed? 25 is not equal to 36, and it is all the hypotenuse's fault. Let's blame the C side. And that C side is, in this case, too big. Too big to form a right triangle. And the fact that it's too big is going to make that angle too big to be a right angle. So what's bigger than a right angle? An obtuse angle. So when your C side is too big, that tells you that you've got an obtuse triangle. If you'd like some more practice, here we go. Make sure that you're always picking that biggest one as your C value. So if you're asked to classify as acute, right, or obtuse, here's what I need to see. I want you to write out the Pythagorean theorem, and I want you to show me the results. So 8 squared plus 15 squared is 289, and 19 squared is 361. That's the work that I want you to show. And then I want you to examine that C side. Is it too big or too small? In this case, too big to be equal. So if they're not equal, it's not a right triangle. And if that C side is too big, we've got ourselves an obtuse triangle. When I get to this next example, I'm not really sure if that's bigger than 18 or not, which is important because I need to choose the largest number as my C. Well, I type that in and it is approximately 13.4. So it does turn out that the 18 would be my value for C since it's the biggest here. And I guess I really shouldn't be using an equal sign. I am checking to see if those are equal. And sometimes we find out that they're not equal. How do we square a 6 root 5? We square each of the parts. So 6 squared is 36, and the square root of 5 squared is 5. 36 times 5 is 180. 180 plus 169 is 349. So again, I found out that this is not a right triangle. Whose fault is it? It's the C side's fault. The hypotenuse was not big enough. It was too small to be a true hypotenuse. And if it's too small to be a hypotenuse, that makes this an acute triangle. One more. Again, we've got a simplest radical form here, so we'd probably want to figure out what that equals before we start. In this case, that comes out to about 10.8, which is good to know because that is the C value. That's the biggest one there. So when I put those in, I'll use that for C. Six squared plus 9 squared is 117. And over on this side, 3 squared is 9. And the square root of 13 squared is 13. 9 times 13 is 117. And so we actually finally got one where the a squared plus the b squared equals the c squared, so we know that is a right triangle. So we're using the converse of the Pythagorean theorem to tell us if we have a right triangle. We can also use it to tell if our triangle is acute or obtuse.